Section 6.4, problem number 15. We're going to solve this equation in 0 to 2 pi using factoring by grouping. First thing I really want to do when I see this ugly equation is simplify it, make it a little easier on my eyes, and I'm going to use substitution. I'm going to substitute all my tangents with a u, so that's going to be a u, and so I'm going to let u equal the tangent of x. And I'm also going to call this guy a v. So I'm going to let v equal cosine of x. Let's see if that will make my eyes a little happier. So I have, I'm just going to copy everything else down in black. So I have 3 u squared times v minus 3v plus 2 equals 2 times u squared. So filling those u's and v's. So instead of tangent squared, I have u squared. Instead of cosine of x, I'll write a v. And instead of cosine of x, I write a v. And instead of tangent squared, I'll write a u, and I forgot my squared. So a little simpler equation now. So I have 3u squared v minus 3v plus 2. And I know that with factoring by grouping, I need 4 terms on the left and a 0 on the right. So I'll subtract the 2u squared from both sides and get a 0 on the right. So now I need a factor by grouping. So I group the first 2 guys in one color, and I can group the other 2 guys in another color. So looking at my blue group first, I want to take the GCF out of that group. And the GCF, the greatest common factor, is a 3v. So I'll take a 3v out, and I'm left with a u squared minus 1. Okay? And then I'll add the second group. I didn't change any values. I'm not changing it to multiplication. It's still addition. I'm not changing values. It's just regrouping, really. So I'm looking at my second group, and my GCF there, my greatest common factor, is a 2, left with a 1 minus u squared. All that still equals 0. The goal when I do factoring by grouping is to get the stuff that's inside the parentheses to be exactly the same. And here we're super close. The only thing we're missing is that this 1 minus u squared is the exact opposite of u squared minus 1. So if I just pull out a minus, so instead of a positive 2 in front, I put a negative 2 out in front, then I'll get negative 1 plus u squared, or I can reorder that to say u squared minus 1, so it looks like our other parenthesis. So I have 3v. I didn't change anything on this one. And I didn't change my 0 because I didn't change any values. Okay, so now I have exactly the same thing in parentheses here and here. So I can treat that like one brand new variable and just take it out in front. And don't just kind of treat it like a one, I don't know, call it a z if you want to. We're putting that out in front. That's a common factor. And what we're left with after we take that out is the 3v minus 2. That equals 0. And now I have a product. This is now multiplication because I factor out the 3v minus 2. I'm sorry, the u squared minus 1. So I'm left with a product. And now I can use a 0 product property. So I have either u squared minus 1 equals 0, or 3v minus 2 equals 0. anytime two numbers multiplied together equals 0, one of them must be equal to 0. Now solving each of those for the variable, I get, let's see, u squared equals positive 1. So taking the square root of both of those sides, I get u equals positive or negative 1. And on the right-hand side, I have 3v, adding 2 to both sides, I get 3v equals 2, so v equals 2/3. Okay, time to look back at what we substituted. We've gone as far as we can go with these variables. Now I need to go back to here and substitute this back in here. So instead of u equals plus or minus 1, I get tangent of x equals plus or minus 1. And instead of v equals 2/3, I get cosine of x equals 2/3. And that looks much easier to solve than our original long problem. So tangent of x equals plus or minus 1. I can look at my unit circle and see what is x going to be. So I'm going to take the tangent inverse of both sides. And I get on the left side, I'll get just x because the tan inverse and the tan cancel each other. And on the right, I have to think, well, on the unit circle, what values will give me, because I'm between 0 and 2 pi, so what values are going to give me a tangent of a positive or a negative 1? And I can see that happens at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So there's 4 possible solutions. Then I still have my cosine possibility over here on the right. So now it's a little tricky. I need to solve for the cosine inverse of this one is a little trickier because it's not on my unit circle. So I get, on the left I just get x, cosine inverse and cosine cancel each other. But on the right, I get cosine inverse of 2/3. I know there's 2 possible solutions in the 0 to 2 pi domain. So, but the calculator is only going to give me 1. So I'll use my calculator to get that 1, and then my wits to get the other. So cosine inverse of 2/3, I want to make sure I'm in radians, so see the radians right here. I'm in radians. And I want cosine inverse, so toggle this till you get a cosine inverse of 2 divided by 3, close your parentheses, and we get that one possibility of x is 0.8411. Our directions say to round to the nearest 4 decimal places, so that rounds to a 1. Now I need to think logically about where that other solution could be. The unit circle has 2 positions where the cosine is equal to 2/3. We just found from the calculator that one of them is at 0.8411. And the other positive cosine would be, so this is in quadrant 1, right? It's less than pi over 2 and greater than 0, so it's in quadrant 1. So its buddy is going to be right across that x-axis, symmetric. So it's going to be 0.8411 of a negative angle, but we need the positive angle. We want to find the angle that is from the positive x direction, so this dark blue line. So to get that, that's like the whole circle, which is 2 pi, but it stops just short of the length of the size of the angle we just found. So that's going to be our second solution for x. So that is, let's see, clear this and do 2 pi minus I'll do the second cosine of 2 divided by 3. Again, so I don't have to round, and then I get 5.44, again rounding to 4 decimal places. So here is another possible solution, just more possible solutions. And don't forget about over here we have 4 other possible solutions. So there's 6 possible solutions to this one.